In this section, you will learn how to translate words into algebraic notation. This is an essential skill for word problem solving. Learning translation skills is important. Research indicates that what distinguishes high scorers from low scorers on the Math SAT is the ability to translate from words into algebraic expressions. If you want to do well on the SAT Math, you need to master this skill. In this section, you will learn how to recognize common verbal expressions indicating addition, subtraction, multiplication, and division. You will also learn how to find algebraic expressions for quantities that have been separated into unequal parts. For example, how to express the fact that 5 gallons of fluid has been separated into 2 containers of unequal volume. You will also learn to recognize which word problems should be solved using proportions. And here are some common expressions indicating addition. For example, if we have the sum of a number and 7, it's x plus 7. 3 more than a number is n plus 3. 9 greater than a number, z plus 9. A number is increased by 5 is x plus 5. The total of 4 and a number, n plus 4. 7 plus a number, n plus 7. A number and 45 is n plus 45. In addition to knowing those key words that indicate addition, you also need to look for circumstances that imply addition, because the problems themselves may not use the specific words discussed earlier. Know that if an increase has occurred, you may need to add. Examples would be a stock price going up, a road being lengthened, traveling above sea level, or a population increasing. Expressions indicating subtraction. The difference of a number and 2, 8 less than a number. Notice that in the verbal expression, the 8 comes first, but in the algebraic expression, the 8 comes after the variable. It's n minus 8, and it's reversed there. A number less 6 is simply x minus 6. 13 is subtracted from a number as x minus 13. Again, notice that the order of the verbal expression and the algebraic expression are opposite. How many more x than y is found by subtracting, that's x minus y. How much greater is p than q is p minus q. Look for situations that imply subtraction. You might look for a decrease in population, the stock market declining, descent to a lower altitude. If you are asked about change, consider subtracting because change is a difference, and the word difference implies subtraction. Know the difference between greater than, is greater than, and how much greater than. Greater than indicates addition. 6 greater than a number is written as x plus 6. How much greater than indicates subtraction. How much greater is y than z is expressed as y minus z. Is greater than indicates the greater than symbol. Y is greater than z is y followed by the greater than symbol and then z. Also, know the difference between less than, is less than, and how much less than. Less than indicates subtraction. 12 less than x is written as x minus 12. How much less than indicates subtraction. How much less is x than y is written as y minus x. Is less than indicates the inequality. Y is less than x is written as y less than symbol x. Here are some phrases that indicate multiplication. 15 times a number is expressed as 15x. The product of 3 and a number is 3x or 3 times x. Twice a number is 2x or 2 times x. 1/2 of a number is 1/2 times x, which is just written as 1/2 x. 12% of a number is 0.12 n. Notice that when you are working with fractions and decimals, if you see the word of in the problem, that will nearly always indicate multiplication. Charlie is 3 times as old as Jerry is C equals 3J. Recognize situations in which multiplication is used. In general, if the same thing or situation is happening repeatedly and you want to find a total, multiply. For example, if you're working for $10 an hour, you're doing that same thing over and over again. Each hour you're working for $10. Therefore, if you want to find your total wages, you would multiply your wage per hour times the number of hours, and that's 10 times 20, for example, is 200. Another example, if a can of paint covers 500 square feet and you use 3 cans of paint, you have painted 500 times 3 equals 1,500 square feet. Here are some phrases indicating division. 8 divided by a number obviously is 8 over n, or 8 divided by n. The quotient of a number in 5 is x over 5. The ratio of 5 to 3 may also be expressed by a fraction, and remember that a fraction implies division. The number in the denominator is what you're dividing by. 70 miles per hour can be written as 70 miles over 1 hour, and the 1 is usually understood instead of written. But per is a rate, and somewhere in there you are dividing. And also, let's talk about phrases such as for every 3 plates there are 2 saucers. To write an equation for that, you would start by writing a proportion. A proportion is 2 fractions set equal to each other. And fractions, remember, imply division. And so you might write P over S equals 3 over 2. Notice that we put P for plates in the numerator of the first fraction, and 3, which is the number associated with plates, is the numerator in the second fraction. If S is in the denominator, and that stands for saucers, the number 2 will be in the denominator of the second fraction. Notice that we can cross multiply and get 2p equals 3s. And I want to talk a little bit more about this phrase, for every 3 plates there are 2 saucers. Inexperienced students are sometimes tempted to write, for every 3 plates there are 2 saucers, and make the equation 3p equals 2s. And that's because 3p equals 2s follows the word order. But this is absolutely incorrect. Remember, in an equation, the 2 sides are supposed to be equal. Since there are more plates than saucers, the variable representing plates would have to be multiplied by a smaller number, and the variable representing saucers would have to be multiplied by a larger number for the 2 sides of the equation to be equal. Let's talk about some more examples of ratios and proportions. For every 4 people who eat cheesecake, 5 eat key lime pie. The easiest way to do this is to set up a proportion with C standing for cheesecake and K for key lime pie, obviously. C over K equals 4 over 5. Notice we've been consistent that if we place C in the numerator of the first fraction, for cheesecake, the number associated with cheesecakes, which is 4, would be in the numerator of the second fraction. Similarly for the key lime pie. Cross multiplying gives 5c equals 4k. For every 6 people who buy Exxon gas, 7 buy Chevron. E over C equals 6 over 7. 7e equals 6c. For every 4 people who like sushi, 9 like pizza. Obviously, we're letting S stand for sushi and P for pizza. And the proportion becomes S over P equals 4 over 9. Cross multiplying gives 9S equals 4P. Let's also talk about some situations that imply division. Division is indicated if you have a total amount of something and in some way want to divide it evenly. For example, if you are given a problem such as a camp has 28 campers and 29 cartons of milk, how many cartons of milk should each camper get? In this situation, you should divide. Another crucial translation skill is the ability to combine several operations when you need to make one expression. Some expressions require 2 or more arithmetic operations. Here are some examples. The sum of 3 times a number and 5 is written as 3x plus 5. Notice, however, the difference between that expression and the expression 3 times the sum of a number and 5. This becomes 3 parentheses x plus 5 close parentheses. Compare the difference of 8 times a number and 7, and that's 8x minus 7, with 8 times the difference of a number and 7, which is 8 parentheses x minus 7 close parentheses. Now let's talk about when to use parentheses. In general, if a word indicating multiplication or division is used before a word indicating addition or subtraction, you will need to use parentheses. Study the examples given in an earlier slide until you understand the pattern between the language and the use of parentheses. Notice that with the phrase the sum of 3 times a number and 5, the word indicating multiplication becomes after the word indicating addition. Sum comes first and times comes second. In that case, we usually don't use parentheses. But look at the example right below it. 3 times the sum of a number and 7. In this expression, the word times, which indicates multiplication, comes before the word sum, indicating addition, and we use parentheses. A similar set of rules applies for words indicating subtraction. The difference of 8 times a number and 7 is 8x minus 7. Notice the word for subtraction, difference, comes before the word for multiplication, times, and we don't use parentheses. But compare this to the next expression, 8 times the difference of a number and 7. Here the word times, which indicates multiplication, comes before the word indicating subtraction, and we use parentheses. Another vital translation skill is knowing how to separate a total amount into 2 smaller unequal amounts. And a lot of the problems with distance problems and mixture problems come from an inability to do this. Whenever you have a total amount, let's call it x, and you've divided it into 2 smaller unequal amounts, the new amounts are x and the total minus x. And an example will help you grasp this. Suppose Bob and Mary are a couple and they're shopping for holiday gifts. They need to buy 38 gifts altogether. If Mary buys X gifts, how many gifts does Bob buy? The table below illustrates the reasoning. To find the number of gifts Bob buys, subtract the number of gifts Mary buys from 38. So let's look at the table. Let's suppose they need to buy 38 gifts and Mary buys 1 gift. We know without even thinking that Bob then has to buy 37, but to find that, we've taken the total gifts, which is 38, minus the gifts bought by Mary, which is 1, to get 37. Suppose Mary buys 2 gifts. How many does Bob buy? Well, he buys 38 minus 2, which is 36. If Mary buys 3 gifts, Bob buys 38 minus 3, which is 35. If Mary buys 15 gifts, Bob buys 38 minus 15, which is 23. And if Mary buys X gifts, Bob buys 38 minus X gifts. Here is another example. Charlie and Rhonda go kayaking. They paddle from Charlie's house to the Bimini Boatyard, their favorite restaurant. The round trip takes them 2 hours. Write algebraic expressions for the time it takes to get from home to the Bimini Boatyard and the time it takes to get from the Bimini Boatyard to home. The time to travel to the Bimini Boatyard we can just call x. Because the total time traveled for the round trip was 2, the time to travel from the Bimini Boatyard to home is 2 minus x. Here's another example. Charlie's sister Jessica has 5 yards of blue fabric. She uses some of the fabric to make a tablecloth and some of the fabric to make napkins. How much fabric does she use for each purpose? The fabric for the tablecloth is X. The fabric for the napkins is the total minus X, which is 5 minus X. Here's yet another example. Charlie buys a 10-gallon keg of root beer for a party. To make it easier to carry, he divides it into two smaller kegs that are not of equal size. Write algebraic expressions for the size of the kegs. The first keg is X, the second keg is 10 minus X. Let's talk about translating expressions in which the word order and the algebraic order are different. Consider the example, there are 4 times as many spoons as forks, where S equals the number of spoons and F equals the number of forks. The wrong way to write this is 4S equals F. This follows the word order, but it violates the logic of math. The left side of an equation must be equal to the right side of an equation. That's the very meaning of an equation. But we need to multiply the smaller amount in this problem by an integer to get it to equal the larger amount. There are fewer forks. Hence, the correct equation is 4F equals S. Here is more on translation. There are 8 times as many canoes as kayaks. The wrong way is 8C equals K. The correct way is 8K equals C. Notice that the smaller quantity must be multiplied by the larger coefficient so that the left side and the right side are equal. Here's a question that involves 2 numbers. For every 4 math books, there are 3 English books. Write an equation expressing this relationship where M equals math books and E equals English books. Perhaps the easiest way is to set up a proportion where math books over English books equals the number of math books over the number of English books. Cross-multiplying gives us 3M equals 4E. Note that the smaller quantity E is multiplied by the larger coefficient, and the larger quantity M is multiplied by the smaller coefficient. This makes the 2 sides of the equation equal. Here are some practice problems. Pause the DVD after each problem or group of problems that's given. When you are finished, come back for the answer. Here are the first 5 problems. Here are the answers. Here are problems 6 through 8, and these require you to know when and when not to use parentheses. And here are the answers to practice problems 6 through 9. Here are practice problems 10 and 11. And here are the answers. Here's practice problem 12. And here's the answer to practice problem 12. Practice problem 13. A chemist has 5 milliliters of saline solution that she wants to separate into 2 parts. Write algebraic expressions for the 2 parts. The answers are X and 500 minus X. This is a good time to add that you will need this skill of dividing mixtures into 2 unequal parts when you do mixture problems. Practice problem 14. Rhonda is a long-distance swimmer and is practicing to swim across the English Channel. She practices by swimming from Deerfield Beach to the Jupiter Inlet and back again. The round trip takes her 13 hours. Write algebraic expressions for the time it took for each of the two parts of the trip. The answers are t for time and the total minus t, 13 minus t. Problem 15. Write an equation to describe the situation. For every 2 dogs that like any brand dog food, 5 like Pampered Pooch dog food. The answer is 5a equals 2p, and the easiest way is to set up a proportion a over 2 equals p over 5. This proportion is set up a little differently than some of the others I've done in this section, but it's still correct. Notice that the symbols for the brands of dog food are both in the numerator, and the numbers of dogs who prefer that particular brand are in the denominator. Cross multiplying gives us 5a equals 2p. A similar problem: for every 2 women who like popcorn, 23 like chocolate. Again, we set up a proportion. We had 2 over p equals 23 over c, and cross multiplying gives us 2c equals 23 over p. Notice that there are many ways that a correct proportion can be set up, but what you need to do is to be consistent. Notice that we have, in this problem, the numbers associated with popcorn and chocolate are both in the numerators, and the symbols for popcorn and chocolate are both in the denominator, and in each fraction, the number of people preferring that particular food are along with the symbol for that food are together. Practice problem 17. Write an equation for the expression below. There are 3 times as many boys as girls in the calculus class. Obviously, the example is 3g equals b. Practice problem 18. There are 6 times as many tennis balls as rackets, where r equals rackets and b equals balls. And the answer is 6r equals b.